Welcome back to the Understanding Alarm Trips video series from More Industries. In Part 3, we explored the many types of alarms available in limit alarm trips, from high and low alarms to more advanced options like rate of change, window or band, and stuck input alarms. We showed how the flexibility of multiple relay outputs and specialized alarming give you the tools to protect your process, whether that means issuing early warnings or triggering emergency shutdowns. Now, in Part 4, we're taking a closer look at these alarm responses by diving into relay contacts and configurations. We'll explain the difference between normally open and normally closed contacts and how relay response types impact your system behavior. Then we'll walk through the most common relay configurations: single pole, single throw, single pole, double throw, and double pole, double throw, so you can understand how each one works and when to use them. We're going to walk you through how alarm trips physically take action. Let's review the basics. Normally open and normally closed relay contacts. The term normal refers to the de-energized or default state of the relay and how it behaves when power is not applied. In this state, a normally open contact doesn't allow current to flow to the common terminal. The circuit is open and nothing happens. But when the relay is energized, the contact closes, allowing current to flow between the normally open and common terminal. A normally closed contact behaves in the opposite way. When de-energized, it forms a closed circuit with the common terminal, so current flows. But once the relay is energized, the circuit opens and current stops. Understanding how these contacts behave is key to designing alarm logic that responds exactly how you need, whether you want something to turn on, shut off, or simply alert when conditions change. Now let's look at the most common alarm relay configurations: single pole, single throw, single pole, double throw, and double pole, double throw. A single pole, single throw relay is the simplest type. It has one input, or pole, and one output path, or throw. Think of it like a basic on-off switch. When the relay energizes, the contact either closes or opens depending on how it's configured. If it's normally open, it allows current to flow only when tripped, perfect for turning something on in response to an alarm condition. If it's normally closed, the current flows until the relay energizes, useful for processes where you want the power to be cut off during a fault. Most alarm trips let you choose between normally open or normally closed, depending on your application. A single pole double throw relay gives you a bit more flexibility. It still has one input, but it can direct the signal to one of two outputs, either the normally open or normally closed contact. This dual path configuration means the same relay can support different alarm strategies without rewiring the hardware, making it adaptable to changing application needs or logic updates. Finally, there's the double pole double throw relay. This type includes two independent contact sets that change state simultaneously. With a double pole double throw, one relay trip can trigger two separate actions at the same time. For example, one output might activate an alarm light, while the other shuts off a valve or starts a blower. It's a powerful option when you need your alarm trip to do more than one thing in response to a single input condition. Understanding these relay configurations helps you match the alarm trip response to your specific application needs, whether that's a simple indication or multi-step safety actions. Now that you've seen how alarm trip relays respond, you now know how normally open, normally closed, single pole, single throw, single pole, double throw, and double pole, double throw configurations work. You're better equipped to choose the right relay type and contact arrangement for your application. Understanding these fundamentals helps ensure your alarm system responds reliably when it's needed most.